Okay, I'm going to do homework problem number 3 from section 12.2 for you. Actually, before I do that, let me do two related problems. Let me graph the plane z equals 2 minus y. And then separately, I'll graph the cylinder x equals 4 minus y squared, and then I'll put it all together for you. So in the first octant, all we really need are the positive x, y, and z axes. I'm going to make this guy coming out of the screen supposedly the positive x-axis, this axis positive y, and this axis z. And remember, if you want to graph z equals 2 minus y, all you need to do is graph the line z equals 2 minus y in the yz plane to start with anyway. So let's go out 2 on both the x and y axes. y2, well, because I know that the intercept on the z-axis and on the y-axis will be 2 for both of these. Plug in 0 for y, you get 2 for z, and plug in 0 for z, you get 2 for y. So this line segment then will generate the plane z equals 2 minus y in the first octant. This line segment right here. So let's translate that parallel with the x, and you get this kind of slanted surface here, flat surface, it's plane. If you wanted to, you could replicate the triangle form between the y-axis, the z-axis, and this line. I hear my son calling me in the background. I don't know if you guys can hear that. Okay. Now it's this face here that's the only part of this picture that's the plane. With pencil, you could shade it in rather nicely. I could make an attempt to shade it in here. Anyway, it's this flat face leaning against the xz plane that's actually the part of the plane z equals 2 minus y. So I don't know how long you want to see me shade this in, but you get the idea. So that part highlighted in kind of the yellowish highlighter is the plane that we're after. Now let's talk about x equals 4 minus y squared. So how are we going to graph that? Okay. Same sort of picture in terms of the axes, x, y, and z. And then think about what the generating curve for this cylinder looks like. It's got to be a parabola, doesn't it? And in fact, it's a parabola opening sideways because in the xy plane, that is, because the y squared, because the exponent of 2 is attached to the y. And okay, if you plug in, just eyeballing it, you can tell if you plug in 2 for y, you get 0 for x. So I can immediately see then that the y-intercept here is 2. So I'm going to put this point in. And then if I plug in 4 for x, I actually get 0 for y. And the parabola in the generating curve, which is a parabola in the xy plane, should open kind of sideways like that. But in the first octant, this is all you're going to see. Of course, it keeps going, right? And then it has another side to it and keeps going like that. But we're not trying to graph that. We just want the part in the first octant. Okay, and then you translate this curve upward. Straight upward, straight down as well, but I'm not going to try to draw that part. And if you can draw a copy of that curve. like so. Not perfect, but it should have been up a little bit higher. Then this curved wall right here is what we're interested in the first octant. And again, I didn't extend it downward because we're not interested in going down. We're only interested in values that are in the first octant. So I suppose I could make an attempt to shade that in too. And so I'm trying to make it look like a wall. It's much easier to do in pencil and paper, but hopefully I'm giving you an idea. So I'm not shading on the inside of this. I'm shading the wall so you can see what the wall looks like. What the boundary looks like, rather. Now, what will it look like if you put these two shapes together? Well, that's the final piece of the puzzle. So this is really now, this part of it is what you need to show me, the work you need to show on your paper. So again, positive x, y, and z axes. Let's try that one again. I had to come out 2 on the y, let's see, 2 on the z, and 4 on the x. So let me bring this out just a little further. 1, 2, 3, 4. And let me reproduce this picture up here. And let's see, slide it on down. Looks something like that. These dotted lines on the side just give it some depth, some perspective. And then, okay, how would this cylinder intersect this plane? Well, here's what I'm going to try to convince you of. Okay, the cylinder then, okay, the generating curve, this would be the vertex, and it goes through the y-axis here. The generating curve would look like that. And then as you translate that generating curve up, it's going to intersect this plane. And where it intersects will be a curve. And what does that curve have to look like? Well, because the plane, you can see in this picture, or the one I just drew, because the plane, as x goes from 4 to 0, because the plane at this end shrinks down to a height of 0, that intersection curve between the plane and the cylinder is going to have to come down like this. From a height of 2, it'll come down, sweep down. Remember, this curve is on the cylinder, so it's got to curve around on the cylinder, but it's also got to lie in the plane. So it's in the flat plane, like so. And so the region that we're really talking about, and really it's a region of space, so it's going to be enclosed, is going to be defined by having this guy in green as one wall. And in fact, it'll be easier to erase. Let me make sure I have the right eraser picked here. It'll be easier to erase this now that we can see what the boundary curve is, that part in green. Okay, so we are enclosing basically this region in the first octant then by this curved wall created by, the cylinder, the parabolic cylinder, but it has a boundary created by the cylinder and this plane up here, Okay, so this is one wall. And then the other side walls are created by, the back wall would be the part of the YZ plane in here. The side wall would be the XZ plane in here. And, those are two of the walls, and then the third wall is given by what I just described here. And then the roof is given by this plane up here. Think of that as the roof of this object. So the roof is given by, the roof lies on the plane. The points on the roof lie on this plane created by whatever the equation was, z equals 2 minus y. And then I'll continue my outline in green here. Make it a little bit more bold than the rest. Actually, it might look better if I do the outline in black. Anyway, that's how you do it. Oh, and I forgot about the floor. I forgot to mention the floor. The floor of this object is given by the xy plane.